Section 5.3 involves a different method than the last one we did for solving these systems, but it's also an algebraic one like the last one, so we're not going to use graphs. Let me start with a reasonably simple example to try to illustrate what I'm talking about. Here, I'm going to give you a system of equations, a very simple one. X plus y equals 10, and x minus y equals 5. Now, the elimination method involves making one of these variables or unknown quantities disappear temporarily while you find the value of the other one. Watch what I mean. If I take these two equations and I add them together, add your like terms, you add the x's together and you'll get 2x, and you add the numbers together, you get 15. But more importantly, notice what happened to the y's. The y's canceled out. They were eliminated. And so we ended up with 2x equals 15. This is an equation you can solve since it only has one unknown quantity. Now I can divide by 2, and I get my x equals 15 halves. So there's half the answer. Now to get the other half, let me write these again. X plus y equals 10. X minus y equals 5. I eliminated the y in the first step. Now I want to go and eliminate the x. The way I'll do that is I will multiply the second equation by -1. Now, this changes the set of equations, at least the second one, to look like the following. X plus y equals 10, and then -x plus y equals -5. Now when I add those two equations together, look what happens to the x's. They are eliminated this time, but the y's remain. 2y equals 5. And then to figure out what y equals, I'll divide by 2. So y equals 5 halves. What's nice about this method is it leaves any fractions that may happen until the very end of the problem. So that's why it's probably my favorite of all the methods. Anyways, our answer is 15 halves, comma, 5 halves. Of course, you should always check these answers by plugging them back into the original equations and making sure that both answers work in both equations. So that's the gist. This is the simplest possible example. I'm going to do more difficult examples as I continue. So let's move on to the next one. So we're going to solve 2x plus 3y equals 10, and x plus y equals 5. Now, it's not quite like the last one. I can't just add them together and eliminate one of the unknown quantities. So just adding these together does nothing for us. So if you do this, I see students do this all the time. You get 3x plus 4y equals 15. While that's a true equation, it doesn't do anything for us. This is a worthless effort. Instead, let me try again here. 2x plus 3y equals 10. X plus y equals 5. I want you to change your thought processes for a second. I want to start out first, I want to eliminate the x's. So if I look at the x's that are involved, I've got 2x and then I've got an x. It would be really nice if this was a -2x. That way when I added them together, the x's would cancel. I don't want to divide this by 2 because then it would introduce fractions, so I'm going to avoid that. Instead, I'm thinking of multiplying the second equation by -2. That way when I multiply it by -2, I'll have a -2x and I'll have a +2x. When I add them together, the x's will cancel. So let's go ahead and do that. So probably the easiest thing is to just rewrite these things each time you do this. And x plus y equals 5. So like I said, I'm going to multiply the second equation by -2. What does that leave me? Then I get 2x plus 3y equals 10. There's one equation. The first one was untouched. The second one, -2x, actually since it's negative, I have to follow through on all of them. -2x minus 2y equals -10. Now I can add them together because the x's disappear, and I simply get y is equal to 0. So there's half the battle. Second half, let me do this again. 2x plus 3y equals 10, and x plus y equals 5. Now what you should do, if you're paying attention or participating while you're watching, you should be taking notes like you're in class. And what you should do at this point is, before I go and solve this, try to do it yourself. Pause the video and see if you can get it. What I'm going to do now is target the y's for elimination. So I see that I got a 3y. It's not a good idea to divide this thing by 3. Keep that in mind. But it is a good idea to multiply this by -3. If I had a -3 in front of that y, it would be really nice. Now, unfortunately, I can't just put a -3 there. I have to do something mathematical. So in my case, I will multiply the second equation by -3. When I do that, I see that I'll have a positive 3y, and I see that I'll have a -3y when I'm done. So I have 2x plus 3y equals 10. -3x minus 3y equals -15. Add them together. The y's cancel completely. I get -x equals -5. And then you can divide by -1 or just reason it out. X is equal to 5. So for our answer, we get 5, 0. For these, it is easy to check yourself. If x were 5, 2x would be 10. The y being 0, this works out, and then x equals 5 and y equals 0 works out for the second equation. This time we have 4x minus 5y equals 2, 3x plus 2y equals 7. Now this will introduce us to the general idea on this whole process. Remember, dividing by any of these numbers is not a good idea. Instead, I want to try to make some x up here and some x up here, one positive and one negative, but the same amount of x. The easiest way that I know how to do this is the following. I'll write these equations again. The first thing I'm going to do is target x for elimination. So I want to come up with some sort of a scheme that will erase the x's, and I'll just be able to figure out what y is temporarily. Well, the way to do that is, the easiest way that I know to do that is, if I were to take this 3 and multiply the first equation by 3, it would give me a 12x. Then, if I take and multiply the second equation by -4, I'll get -12x. Where did I get the 4 and the 3 from? Well, they're sitting right in front of me. The 4 is here and the 3 is here. That's what gave me the idea to use these numbers. I know that 4 times 3 is 12. So the first equation, I'm going to multiply by 3. I'll get a positive 12x when I do this multiplication. For the second one, I'll multiply by -4. This time I will get a negative 12x. Now what do these become? The first one becomes 12x minus 15y equals 6. The second equation becomes negative 12x minus 8y equals negative 28. Make sure when you multiply this through, you multiply it through all three pieces of the equation. Now I'm ready to add these two things together. What I did was exactly necessary to make a positive 12 and a negative 12. When I add them, the x's of course cancel as designed. I'll get negative 23y equals negative 22. And then I'll divide by negative 23 to get y equals 22 over 23. Now if this were the substitution method, you would have to take this horrible thing, plug it back into some previous equation, and deal with that horrible fraction. But this method avoids that till the last step. How do I go about getting the x's now that I know the y values? I'll write them again. 4x minus 5y equals 2, and 3x plus 2y equals 7. Now if I'm targeting the y, so target y for elimination this time. So with that in mind, notice that one is already negative and one is positive. So that's half the battle. What I can do is, looking at this 2, if I multiply the first equation by 2, it'll give me a negative 10y in that spot. If I multiply the second equation by 5, once again, I got the 5 by looking at this number here. There it is. Notice when I multiply through, I'll get a positive 10y. So we'll have a negative 10y and a positive 10y. What do these become? I get 8x minus 10y equals 4. And then I get 15x plus 10y equals 35. Now when I add them together, the y's will drop out and I will get 23x equals 39. So I can divide by 23 to get x is 39 over 23. So my answer then is 39 over 23, comma, 22 over 23. And this is usual too. Notice that y had an answer whose denominator was 23, and the same happened for x. That usually does happen because of the numbers that we're dealing with. All right, let's keep going. Solve. Let me see, I have 7x minus 4y equals 8. Then I have 8x minus 3y equals negative 5. So I'll leave that there for reference purposes. But first I'm going to target x for elimination. So let me write my equations again. 7x minus 4y equals 8. 8x minus 3y equals negative 5. So I'm going to do exactly like I did before. I'm going to put an 8 in front of the first equation and a 7 in front of the second equation. That way they're both 56x when I do the multiplication. However, one of them's got to be negative. So I'm going to throw a negative on, attach that one. It really doesn't matter so long as one of them's negative and one of them's positive. What do my equations become? I get 56x minus 32y equals 64. Then I get negative 56x plus 21y equals negative 35. So when I add these together, Careful. Negative 7 times negative 5, that's positive 35. So I'll take that out of there. So what do I get for my y's? I end up with negative 32. The x's, of course, cancel. I get negative 32 plus 21 is negative 11y, and that's equal to 99. I'll divide by negative 11, and it looks like I get y equals negative 9. Well, that worked out nice. Now I'll target the y. So we have 7x minus 4y equals 8. 8x minus 3y equals negative 5. So as before, I see this 3 in front of the y for the second equation, so I'll put it up here at top. And then I see the 4 in front of this y, so I'll put the 4 out here. This way I'm going to get negative 12y for both of them. Well, this will be negative 12y when I'm done in the first equation. The second equation will also be negative 12y. Those won't cancel. So I'm going to have to adjust this. I'm going to change this 3 up here to a negative. That way I'll have a positive 12y in the first equation. So let me multiply that through. We have negative 21x plus 12y equals negative 24. And then we have 32x minus 12y equals negative 20. So we'll add these two things together. And I have negative, oh no, actually this time it's a positive 11x. And the y's cancel, equals negative 44. So when I divide by 11, x equals negative 4. So keep this in mind. This is technically negative 99 over 11. This is technically negative 44 over 11. The fact that they no longer have a denominator is sheer luck. These numbers just happen to work out well. So my answer is negative 4, comma, negative 9. This one looks pretty bad right from the beginning. 1/4 x minus 2y equals negative 3/4. And then I have 1/5 x plus 1/2 y equals 12. Now before I actually go about solving this thing, I want to rid it of all fractions just so I have an easier system of equations to work with. So look at the first equation. All the denominators are 4. So I'm going to multiply the first equation by 4. I'm not actually solving anything. I'm just trying to make the equations look better. So when you do that, 4 times 1/4 x will produce simply an x. 4 times negative 2y will have negative 8y. And then finally, 4 times negative 3/4 will be negative 3. On the other hand, I want to get rid of a 5 in the denominator and a 2. The LCD of 1/5 and 1/2 is 10. So I'll multiply the second equation by the LCD, which is 10. Then, when I do 10 times 1/5 x, it'll give me a 2x. Then when I do 10 times 1/2 y, it will give me a 5y. And the other side, 10 times 12 will be 120. So these are the two equations that I'm going to work with instead of the ones I was given. So once again, we'll first start by target x for elimination. So let me rewrite my equations down. All right, so now, well, interestingly enough, I see this has a 2x, this just has an x. If I multiplied the first equation by -2, I don't have to do anything to the second equation because I'll have a -2x already and a +2x. Perfect. Let me go ahead and write down what these new equations are. So I get -2x plus 16y equals 6. Then I'll have 2x plus 5y equals 120. It was unaffected, of course. Let's add these together. I get 21y equals 126. Divide by 21, and you'll find that y equals 6. So half done. Now rewrite the equations again, but this time target y for elimination. So let me write my equations again. Now, I think I see my 8 and 5, so I'll put a 5 in the first equation to multiply the first equation with the 8 for the second equation, and let me check my signs. This 5 times -8y will give me -40y. 8 times +5y will give me +40y, so the y's will get eliminated when I add them. First equation is 5x minus 40y equals -15. And then I have 16x plus 40y equals 8 times 120 is 960. They make this 6 look more 6-like, although it looks terrible now. But let's add these two things together. I get 21x equals 945. And so I'll divide both equations by 21. And let's see what we get. 945 divided by 21. Oh, it comes out exactly 45. So x equals 45. Now notice, by the way, this type of problem, while the answers turn out to be nice whole numbers, and it could have been graphed, it's unlikely your graph would have been big enough to accommodate the x equals 45. Anyways, let's put my answer, 45, 6. Well, if there's fractions, then I guess it wouldn't be too much of a surprise to see decimals. And I'll proceed just like I did before, except you can, if you want to, you can multiply everything by 10 to wipe out all the decimals. But personally, I don't find the decimals difficult to work with. So I'm going to work the same way I did before. Target x for elimination. And so let me write my equations down again. All right, so if I want to get rid of the x's, if I multiply the first equation by 8 and the second equation by 7, I sort of got my numbers from the numbers in front of the x's here. 8 times 7 is 5.6. So in the first equation, I'll have -5.6x. The second equation, I will have +5.6x. So let me go ahead and do that. -5.6x And then when I do 8 times 0.3, I'll get 2.4. And then 8 times 4 will be 32. For the second equation, I'll get positive 5.6x. 7 times 1.8. You are allowed to use your calculator for these, by the way. But I think I'll do them in my head as much as I can. I think I'll get 12.6y there. And that equals negative 77. Let's add these together. The x's are wiped out. And I get 15y equals negative 45. I'll divide by 15. And I get y equals negative 3. So that takes care of the y's. Now let's target y for elimination. And once again, let me write my two equations down. Negative 0.7x plus 0.3y equals 4. 0.8x plus 1.8y equals negative 11. So now let me scan the two y's. You could multiply the first one by 18 and the second one by 3, and then you'll get a 5.4. That'll be fine. I just happened to notice this though. Did you notice that 0.3, if I multiply it by 6, I'll get 1.8. So what I'm going to do, I touched something bad. So what I'm going to do is multiply the first equation by negative 6. The reason I'm choosing that is because it will give me a negative 1.8y, and then the y's can cancel. So when I multiply it through, negative 6 times negative 0.7 is 4.2. Then I get negative 1.8y equals negative 24. For the second equation, I'm going to do nothing to it. 0.8x plus 1.8y equals negative 11. Let me add. I get 5x equals negative 35. Divide by 5, and you get x equals negative 7. So my answer for this one is negative 7, comma, negative 3. What I encourage you to do is to do this one again, but first multiply everything by 10 to eliminate the decimals. Retry the whole problem. Make sure you get the same answers that I do. Now, there's a couple of situations I've avoided. They're not hard situations. In fact, I'm going to attack them with very simple examples. Here, suppose we want to solve negative x plus 5y equals negative 5, and x minus 5y equals 5. Now notice that the numbers in front of x, one is already the negative of the other one. The same happens to also happen to y. When I add them together, I'll get 0 equals 0. What this means is there's an infinite number of solutions. Now I noticed when working some of the homework problems that there's two parts to the answer. One is that you tell it there's an infinite number of solutions, but then you explain to them what type of solutions. So here's what you do. Take the first equation. You have the negative x plus 5y equals negative 5. I don't care if you take the first or the second equation, it doesn't matter. I'm going to solve this equation for y as if I was graphing. So the first thing I would do is add an x. Then I would divide by 5. And so you get y equals 1/5 x minus 1. So this is what they put. They put an infinite number of solutions of the form y equals 1/5 x minus 1. This whole thing is what you would put in for the answer to those types of problems. If you'd have solved the second equation, you actually would have ended up with exactly the same thing as I had there. And another type, solve. Here we have x minus 2y equals 6. Negative x plus 2y also equals 6. So when I add these two together, I'll get 0 on the left, but I'll get 12 on the right. This is very simple. This simply means no solution. We've seen this before. And then that's essentially all there is to it. There's one last thing I wanted to talk about, and that's choosing a method. Usually, most tests that I give have a problem on there that says pick the method that you want to solve one of these problems. And so how do you choose? Well, to be honest, I always choose elimination unless it seems obvious to use something else. So let me do an example of what I'm talking about. As an example, solve. I have 2x minus 5y equals 7. And then I have 7x plus 3y equals 10. Now for this one, I don't see graphing as such a great idea because I would have to solve each of these for y, and I don't think I want to do that. I don't see substitution, obviously, as a situation here because I don't have any letter explicitly solved for. So in my mind, when I see something like this, I'm thinking the elimination method. And so you would proceed just like you would. I would target x first. So I have 2x minus 5y equals 7. 7x plus 3y equals 10. And then as usual, I see the 7 and a 2 out front. So I'll multiply the first by 7 and the second by 2. And then check the signs. I have a positive 14x in the first equation, a positive 14x in the second equation. That won't do. So I'll force the second equation to have a negative 14x. So I get, for the first equation, 14x minus 35y equals 49. Second equation, I get negative 14x minus 6y equals negative 20. When I add them together, I get negative 41y equals 29. Divide by the negative 41, and I get y equals negative 29 over 41. Then I'll target y. So I'll look now at the 5 and the 3. I'll put a 3 on the first equation and a 5 on the second equation. So now let me check my numbers. I'll have negative 15y in the first equation, 15y in the second equation. So they'll cancel. Let me rewrite my equations now. For the second one, I have 35x plus 21y. Made a mistake there, didn't I? Plus 15y. equals 50. Add them together and I get 41x equals 71. And so x equals 71 over 41. And you can see they both have the same denominator again. That should make you feel a little bit comforted when you get your second answer and it shares the same denominator as the first one. So my answer then is 71 over 41, comma, negative 29 over 41. Now, I am not quite sure why this system of equations causes students any problems. To most of us, we could simply say the answer, I don't want to say to most of us, but to those who have studied this more, the answer is clearly going to be 7, 9. But I did kind of want to show you why. There's no substituting that you can do here. There is no elimination that you can do here. You're stuck with it just as it is. So while I'm here, I thought I might show you something that you might find useful for your own work. Let me go and to Google and show you what I'm looking for. This is a free, you don't even have to download it. I like this program called Geogebra. Enter. And I like the classic one, to be honest. I think I can just click right there and enter it, and let's see where it takes me. So what it is, you can see it right here. It's a graphing program. Now the beauty of this is I can type in x equals 7, enter. Let me show you what happened to the equation. I'm going to make this the full screen. If I click in here, that thing will disappear. Do you see what happened here? It's right there. This thing right here is x equals 7. Remember, it's a vertical line. While I'm here, knowing what's coming next, I'm going to drag this down a little bit. And for the second equation, let me put y equals 9. You see this? See where they crossed right there? Look, the point that they cross at is when x equals 7 and y is equal to 9. Let me zoom out a little bit. And down like this. There's a little more that I want to do as far as the setup and everything. Oops, didn't mean to do that. And I think it's in here. Yes, this is what I want. The grid, I want to do just major grid lines so that I don't have a bunch of stuff in the way. And then for these x and y axis, put a distance of 1 and enter. I encourage you to play with this program. You don't have to download anything. All you got to do is go to the website. And let's see what I did. There it is. You can see the equations there. Let me go ahead and copy this into our workbook. And then I can paste it in here. I don't know how much space I'll need for it. Let's see if I paste it right about there. Oh, that looks good. Perfect. You can see this line, I'll put the little things on the end of them. This was x equals 7, and this line was y equals 9. So this dot right here, where they intersect, is at 7, 9. That's the solution. This, to be honest with you, is probably the only problem that I would prefer to do graphing. If I did not know that off the bat, I would graph these things and find out where they intersected, because the other methods simply are not available. You can't substitute and you can't eliminate. And then one last example. Once again, solve. We have negative 5x plus 8y equals 3. And for the second equation, I have 2y equals 2 minus x, like so. Here, to me, it's pretty clear that substitution seems like the easiest thing, because you almost have y by itself. In fact, all you have to do is to divide by 2, and then I can take this and plug it into the first equation. You're going to plug it in for y. So, let me see what my first equation becomes. Negative 5x plus 8 times 2 minus x over 2 equals 3. And so let's see if we can figure out what x is going to equal from this. Notice that I can cancel this 2 into the 8. So that's nice. I get negative 5x plus, now don't forget to multiply the 4 through. So I'll have 8 minus 4x and that's going to equal 3. Now let me combine my x's. And then solve for x. I'll subtract 8, divide by negative 9, and then to go about getting y, I'll use this formula. Y equals 2 minus x over 2. This gets a little bit hairy, as watch what I have to put in for x. I have to put 5/9 up into that little spot. And so how do you work something like this? There's an abundant ways to do it. I'm going to try to go as most straightforward as I can, and that will be to rewrite the 2 as being 18 over 9 so that I have common denominators. Now this 2 at the bottom, change it to a 2 over 1 so you know what to do with it once you've simplified the numerator. So here I'll get 13 over 9 divided by 2 over 1. Then I'll flip the 2 over 1 and I'll get 13 over 9 times 1/2. And so it looks like I'll get 13 over 18 for the y. That was long. Where was the x anyways? X was 5/9. So our answer then is 5/9 and 13 over 18. Notice the denominators are different, but not much different. If you think of this answer as 10 over 18, then I guess they're not really different. But there's one very last thing I wanted to do, and I wanted to redo this last example to show you things that are available to you if you keep your mind open to such substitutions. You'll see what I mean in just a second. Notice I happen to see this 8y, and this is the way I saw the first equation. In my mind, the first equation looked like the following. Negative 5x plus 4 times 2y equals 3. I couldn't help but see the 8y broken down as to 4 times 2y. Why would I see that? Because I see a 2y here. That means all I have to substitute into this spot is the 2 minus x. So this 2 minus x can replace the 2y into that spot. You do not have to do this method. I'm just saying that any little things that are very simple, you can take advantage of them. So I have negative 5x plus 4 times 2 minus x equals 3. Let me go ahead and multiply through and solve. Negative 5x plus 8 minus 4x equals 3. Negative 9x plus 8 equals 3. And you'll see x will get to be 5/9, just like it was before. Now, unfortunately, I don't have much I can do about the y. We have 2y equals 2 minus x, or 2 minus 5/9. And I'll do the same thing. If I think of the 2 as 18 over 9, I can get a 13 over 9 on the right, and I have a 2y. So you're saving yourself a little bit of work on this part. I would multiply both sides by 1/2, and I'll get a y equals 13 over 18, which agrees with what we got last time.